Welcome everybody. In this lesson we will be looking at section 6.6, the law of total probability. And then the next lesson we will be looking at 6.6 Bayes' theorem. But in this one we're just going to focus on the law of total probability. So recall the general rules of probability that we saw in some of the other lessons. For any two events A and B, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. That's number 1 in purple. Number 2 in blue, the conditional probability formula. The probability of A given B is equal to the probability of A and B divided by the probability of B. If we were to kind of flip that condition and look at the probability of B given A on the right, that would be equal to the probability of B and A divided by the probability of A. Same formula, just flip-flopping the letters. Now, from each of those, if we want to get the ands in the numerators in blue by themselves, we can simply multiply what's in the denominator to the other side of the formula, and we get number 3, the general multiplication rule, as it's called. The probability of A and B is equal to the probability of B times the probability of A given B. And similarly, the probability of B and A is equal to the probability of A times the probability of B given A. Again, both of those green formulas just came from the blue formulas above them, where we got the numerators by themselves. Okay, but again, that's called the general multiplication rule. That's going to come up in the law of total probability. That's the one that comes up the most, so you'll see how we end up using that to derive the formula for the law of total probability and answer questions such as the following. Let's take a look at these scenarios. Number 1, suppose a baseball pitcher throws a fastball 75% of the time and throws a curveball the other 25% of the time. If the pitcher strikes out 30% of batters with the fastball and strikes out 20% of batters with the curveball, then what is the total percentage of batters this pitcher strikes out? In the second scenario, in this class, AMAT108, final grades are calculated using the following weights. Your web assignments or homework are 25% of your overall grade. Quizzes are 25%, tests make up 30%, and the final exam is 20%. If a student ends the semester with a 92% homework average, a 74% quiz average, an 80% test average, and got a 75 on the final exam, what grade would they have earned for the course? If you were to flip a coin and roll a die, what is the probability you were to roll a 2? And in number 4, a basketball player makes 34% of their 2-point shots, 17% of their 3-point shots, and 64% of their free throws. If 65% of total shots are 2-point attempts, 28% of their shots are 3-point attempts, and the remaining 7% of shots are free throw attempts, what is the total percentage of shots made by this player? Okay, so in each of these scenarios, we can actually use the law of total probability to answer these questions and come up with these overall total probabilities. So here's the idea behind the law of total probability, and then we'll come back and answer these questions. Suppose we have two mutually exclusive events, we'll call them B sub 1 and B sub 2, where the probability of B1 plus the probability of B2 equals 1. So two mutually exclusive events whose probabilities add up to 1. Then for any other event E, we get, and here's the law of total probability. The probability event E occurs is equal to the probability event E and B1 occur together, or the probability E and event B2 occur together. Well, in probability land, the word or usually means to add. So what we're looking at is the probability event E and B1 occur plus the probability events E and B2 occur. Now, using that general multiplication rule above, rule number 3, I can take these and probabilities and rewrite them using the product of a conditional probability. So the probability of E and B1 becomes the probability B1 times the probability event E occurs given B1 occurred. And the probability event E and B2 occur becomes the probability B2 occurs times the probability event E and B2 occurs. And so the overall probability of event E occurring is given by the third line in green, the probability of B1 times the probability event E occurs given B1 occurred, plus the probability B2 occurs times the probability event E occurs given B2 occurs. That's the formula if there are two mutually exclusive events, B1 and B2, whose probabilities add up to 1. Now, in purple, more generally, if there are a series of mutually exclusive events, B1, B2, so on and so forth, up to B sub k, however many different events they may be, whose probabilities all add up to 1, right? If we add all their different probabilities together, again, we get 1. And then for any other event E, we get the probability event E occurs is, well, the probability event E occurs and B1 occur, plus the probability event E and B2 occur, plus ... all the way up to the probability event E and that last B sub k event occurred. And then again, using the law of multiplication or the general multiplication rule, we turn those and probabilities into products of conditionals. So in general, the probability event E occurs is given by the probability of B1 times the probability of event E given a B1 occurred, plus ... the probability B sub k occurs times the probability event E occurred given B sub k occurred. Now the notation can be a little bit burdensome here, but once you get a hang of it and know how to multiply the appropriate numbers together, actually coming up with these answers, these probabilities, isn't too bad. Ultimately, if you can master the notation, it's just going to show a high level of understanding, but as long as you can get away with coming up with the correct values, knowing what to multiply and add together, you should probably do all right with this stuff. So let's start by taking a look at the coin example, because that's, without question, the most straightforward one. If we were to flip a coin and roll a die, what is the probability we roll a 2? Well, flipping a coin and rolling a die are independent events. So really, what we get when we flip the coin is not going to have any sort of effect on us getting a 2. In general, the probability of rolling a 2 is 1 out of 6. I think intuitively we know that. So if we were to flip a coin and roll a die, regardless of what we get on the coin toss, the probability we get a 2 is just going to be 1 out of 6. Intuitively, we should kind of know that this is our answer going in. All right? But to tie it to the notation, here, let's let rolling a 2 be like event E in the formula above. Heads and tails are events B1 and B2. They are mutually exclusive events. Okay? So, the probability event E occurs is given by the probability of B1 times the probability of E given B1, plus the probability of B2 times the probability of event E given B2. All I did was write down the formula, but let's now tie it to what we're talking about here. B1, let's call that probability we get ahead. Okay, so we'll define those events B1 and B2. And of course, rolling the 2 is event E. So let's think about this. We already know the answer is going to be 1 out of 6. But again, here's our notation. Now the probability of B1 is the probability we get ahead. What's the probability we get ahead when we flip a coin, folks? 1 out of 2. Now, probability of E given B1 represents the probability we roll a 2 given we got ahead when we flip the coin. Well, the probability we roll a 2 given we got ahead is just 1 out of 6. Doesn't matter what we got on the flip of the coin. The probability we rolled a 2 is 1 out of 6. Adding it now, probability of B2 represents the probability we get a tail, which of course is 1/2. The probability of E given B2 represents the probability we rolled a 2 given we flipped a tail. But once again, the fact that we got a tail on the coin toss doesn't really impact the probability of getting a 2 when we roll the die. That's still 1 out of 6. Now, putting things together, we end up with a 12th plus a 12th, which is 2/12, or 1 out of 6. Which again, intuitively, is what we would have expected. The probability we roll a 2, regardless of when we flip a coin or not, is going to be 1 out of 6. But this is just an example of how we can tie the notation to the mathematics and end up with the correct example. Let's take a look at the other examples. Suppose a baseball pitcher throws a fastball 70% of the time and throws a curveball the other 25% of the time. So right away, we should have an understanding that these are mutually exclusive events. The pitcher's either going to throw the fastball or they're going to throw the curveball. And if you notice, the percentages add up to 1, right? So these are our mutually exclusive events. These are like the B1 and the B2 in the formula, okay? But I'm not going to use that notation. I'm going to use different notation that I like for this problem. Now, if the pitcher strikes out 30% of batters with the fastball and strikes out 20% of batters with the curveball, what is the total percentage of batters that this pitcher strikes out? Now, we should intuitively expect a percentage somewhere between 20 and 30. They strike out 20% of the batters with one type of pitch. They strike out 30% of batters with the other type of pitch. So the overall number of batters or percentage of batters should be somewhere between the two. Okay, but let's see what we get back. So in terms of notation, okay, we have our two mutually exclusive events, throwing the fastball and throwing the curveball. So I'm going to use F for fastball and C for curveball. I'm going to use the letter X to represent a strikeout. Okay, so ultimately we want the total percentage of batters this pitcher strikes out. We want the overall percentage of strikeouts, or the overall probability of strikeouts. If we were to randomly look at one of these pitchers' pitches, what's the probability that it would have been a strikeout? So here, we're looking for the probability of X, probability we get a strikeout. Now, in terms of the notation, this is going to be, well, think about the ways they can get the strikeout. They either get the strikeout and through the fastball, or they get a strikeout and through the curveball. So this is like the first line of the notation. The probability of X equals the probability of X and F, or the probability of X and C. And from here, we can now apply the formulas for the general multiplication rule. Now, what we have here are a couple of pieces of data representing the percentage of batters who were struck out. 30% of batters were struck out with the fastball. That's not the percentage of batters that were struck out and received the fastball. That's actually a conditional probability. That 30% represents the percentage of batters who struck out given they saw the fastball. Okay? 30% of strikeouts came from the fastball. That is a conditional probability. That's the probability of X given F. Similarly, with the 20%, right? The pitcher strikes out 20% of batters with the curveball. That's the percentage of batters who were struck out given the pitcher throwed the curveball. That, again, is a conditional probability. And that's the thing you want to try to understand when you're reading these types of problems. Typically, what we're given is some sort of a conditional probability. And that's exactly, again, what the 30 and 20% represent here. So now, expanding on our formula, the probability they get struck out and they saw the fastball, the probability of X and F is going to be the probability of F times the probability of X given F. What's the percentage of times they threw the fastball times the percentage of time that they struck out the batter given they threw the fastball? And the same idea works for the probability of X and C. That's going to become the probability that they, or the percentage of time, I like that wording, the percentage of time that they threw the curveball times the percentage of time they struck out the batter given they threw the curveball. And now we take basically all of our numbers and we put them together, all right? And if you think about it, look, the probability they threw the fastball, or the percentage of time they threw the fastball, was 75% times the percentage of time they struck out the batter with the fastball. So we're putting those pieces of information together. And for calculating the probability they struck the batter out and threw the curveball, we're looking at the percentage of time they threw the curveball times the percentage of time they struck out the batter given they threw the curveball. Again, looking up at the data, it's finding the right numbers to put together. Percentage of time they threw the curveball was 25% times the 20% of the time they struck out given they threw the curveball. And now, multiplying and adding, let's see what we get. I am getting 0.275, which is 27.5%, which indeed, going back to the comments I made earlier, is indeed somewhere between 20 and 30%. So overall, 27.5% of this pitcher's batters are struck out. Again, the notation is tough, but ultimately, if you can find the right numbers to multiply together to come up with the right answer, you've got it. Let's look at the next scenario. All right, in AMAT108, final grades are calculated using the following weights. Your homework is 25% of your grade, quizzes are 25%, tests 30%, and final exam 20%. Again, if you add those up, they add up to 100%. Those are our series of mutually exclusive events here. If a student ends the semester with 92% homework average, 74% quiz average, 80% test average, and they got a 75 on the final, what grade would they have earned for the course? Okay, so again, something like this, weighted averages, is a great application of the law of total probability or law of total percentages. Okay, in this case, again, we have 4 different categories of grades: homework, quizzes, tests, and final exam. These are our mutually exclusive events. So I'm just defining some events here, okay? I'm going to, again, work on the notation. So I've given different letters, different meanings here. W for WebAssign, Q for quizzes, T for tests, E for final exam grade, and F for final overall course grade, okay? Now, look, we have the individual percentages. We know homework is 25%. So the percentage of the grade that goes to WebAssign, 0.25. The percentage of the grade that's associated with quizzes is 0.25. The percentage of the grade associated with tests is 0.30. And the percentage of the grade that is associated with your final exam is 0.20. It's the final exam percentage, or the final overall grade percentage, that we're looking for here. Now, in terms of the grades we've been given, a student ends the semester with a 92% homework average, right? That's a conditional probability. That's the percentage of their homework or WebAssign grade that they earned. If I want to notate that, that's the percentage of their final grade given it came from WebAssign, okay? And again, this is where things are going to get ugly and the notation can get really tricky. So you know what? Let's skip it. Let's do it like this. Instead of trying to tie a bunch of notation together, let's find the appropriate things to multiply together. We need the percentage of the grade that goes with WebAssign times the percentage of the grade that came from WebAssign. We know WebAssign makes up 25% of the grade, and they had a 92% average on WebAssign. So in terms of the percentage for their final grade, okay, just talking in terms of WebAssign, it's the percentage of the grade that WebAssign is worth times the percentage that they earned. they earned 92% of that 25% of the grade. Okay? Let's talk about now quizzes. Quizzes are 25% of the grade, and this student had a 74% quiz average. So again, the 25% is out front times the percentage of their grade they earned that came from their quizzes, 74%. Again, the way to think about this is like of that 25% of the grade, they've earned 74% of that. Okay, moving on. Test grade. Tests are 30% of the grade, and this student had an 80% test average. So those will go together. 0.3 is the percentage of the grade due to the tests times the percentage of the grade they earned given from tests. And finally, for the final exam, they got a 75% on the final exam, and the final exam is worth 20% of the grade. Okay, and so again, careful using decimals, those percentages in there. And let's see what we get. Well, this student would have ended up with an overall average of 0.805 or an 80, which would have been a B- for the course. So not too bad. Good homework grade. Moderate quiz and test averages, decent overall grade for the course. But again, the thing to try and see here, all right, is what we're multiplying together and adding together to get these final values. Let's take a look at the last example. A basketball player makes 34% of their two-point shots, 17% of their three-point shots, and 64% of free throws. Now, if 65% of their total shots are two-point attempts, 28% are three-point attempts, and the remaining 7% are free throw attempts, what is the total percentage of shots made by this player? So the different types of shots are mutually exclusive events here. The person's either taking a two-point shot, a three-point shot, or a free throw. Okay? At the end of the day, we want the total percentage of shots made. So again, it's knowing, what to multiply together here. Okay? 65% of total shots are two-point attempts. What percentage of two-point shots are made? 34%. Okay. Let's see, 28% of shots are three-point attempts, and 17% of their three-point shots are made. And finally, 7% of their shots are free throws, and they make 64% of their free throws. So here we have our setup of 0.65 times 0.34, dealing with the two-point shots, plus 28% of the shots are three-point shots, of which 17% of those are made, plus the remaining 7% of shots are free throws, and 64% of those are made. So punching this in, we get that this particular basketball player makes a little more than 31% of their overall shots. Now, does that make sense? Let's see. 34% of 2 points are made, 17% of 3 points are made, and 64% are made. So I would expect the overall probability to be somewhere between the high and low, which is between 17 and 64, and indeed it is. It's probably closer to the lower end because a larger percent of their shots are 2 and 3 point shots, and they miss those. Okay, but in any event, this is the law of total probability. Has some useful uses here, particularly for coming up with final grades. But if you have any questions, shoot me an email. Talk to you guys.